Hi guys, welcome back to the channel. Today we'll be diving into an in-depth tutorial handling user inputs and arguments in Linux Bash. Whether you are an advanced user or a master student looking to refine your understanding, this lesson will help you dive deeper into the subject. Getting to the core aspect of it, in file handling, usually the user's inputs and arguments in Linux are accepted through positional arguments. There are different kinds of arguments such as $1, $2, asterisk symbol, $hash, and more. The read command is also another interactive way of accepting user input. We will also talk about some real world application of these scripts. By the end of the video, you will have a better understanding as to how to handle user input effectively, and you will be able to move on towards writing your own scripts dynamically in order to adapt to the user arguments which have been given. The first part is understanding positional parameters. What are positional parameters? Well, in Bash, positional parameters allow you as the user or the developer to pass arguments to the script from the command line. These arguments are assigned to variables automatically. In order to use this, you basically follow a structure which you might already be familiar with, like something $1, $2, $3. These refer to the first, second, and third arguments respectively, while $0 refers to the script's name itself, while the $hash symbol basically gives us a total count of the arguments which have been passed. $@ symbol and $star are also used for handling arguments as single entity or separate words. So if you pass something like $@ or $star, you can basically pass values as a single entity or a separate word. So let's try to see this in action. The first script that we will be writing is a simple script for demonstration of positional parameters. We will create our script in VI editor. We call it positional.sh. we go into insert mode /bash. We are importing the bash shebang into our script to get the interpreter into our script. We will write echo. We will like to get hold of the script name, which would appear next to this particular term. So here we would write $0. Next we will write echo the first argument which has been passed by the user. We will write it as $1, and the same structure follows for the second argument and the third argument as well, and this goes on depending on the number of arguments which have been passed. In order to print out or to display all your arguments together, we basically use the $@ symbol. So we will write $@. In order to display the count of all the arguments which have been passed, we would basically represent that as $hash. So this is pretty much the way positional arguments and the different kinds of positional arguments which are used. Let's try to get a better understanding. This is our shebang. The first echo statement would print out the script's name. This is usually done for the purposes of debugging. The second echo statement would display the first argument which has been passed, and this process would go on for the second and the third arguments as well. You can keep increasing the value to $4, $5, and so on, depending on the number of arguments which have been provided. In order to display all the passed arguments, you would basically follow up with $@ symbol. If you would like to display all the counts of the argument and you would try to print out the number, you would basically follow up with $# symbol. So let's quit out of our loop and let us execute this particular script. So we will write positional.sh, and let's say we give it a list of string terms related to fruits. So let's just give it something like this and hit enter. As you can see, as expected, our output basically shows the name of the script, the first, second, and the third arguments. The total number of arguments has been displayed here, and all the arguments have been printed all at once. So yeah, if you pass, let's say, no arguments, that is if $1 and $2 values are empty, it will return 0, meaning that none of the arguments were actually passed. So let's just try that. If we just remove all the arguments and hit enter, you can see that though the script executes, since we didn't give it a argument to be worked on, so it would basically give out 0. Therefore it's essential that you would check if these arguments exist before you execute your script. Yeah, so let's say you want to basically check if these arguments exist. So you can basically say if statement. So we can go back to our positional argument. Let's go into insert mode, and let's say, for the purposes of demonstration, I would just set it up something like this. If, let's say, $#, since the count is not less than 2, if it is less than 2, then we would basically echo out a statement, error, at least 2 arguments are required. Then we would just exit, close the if statement. So yeah, let's just try to again execute this. So with this, our good old arguments, apple, banana, and cherry. If you do so, you don't see that condition. Let's just execute it without any arguments. You can see that our if condition has got that, and therefore it has printed out that error message as well. So yeah, you can basically use argument validation such as this to prevent such unintended scripture failures. At and $* are useful as they would treat your arguments as separate strings. So yeah, let's just move on to the next section. We would now talk about the read command. The read command is a command for an interactive input to be given. Let's say while you are passing arguments, whenever you are executing the script, you would like to prompt the user for a dynamic input from the read through the read command. So this basically allows you to have a script which is far more interactive in nature. So let's say we basically write a user input script. Let's say vi user underscore input .sh. bin/bash. Let's write echo, enter your name, and we would basically read this information into the name variable. So here the user input would be stored into the name variable, and we would echo out the name through a greet message. Welcome to Bash scripting. So yeah, let's just read and write and execute. So yeah, let's just try to execute this. Once you enter, you can see that we are basically paused, and therefore the execution has stopped, and it is basically waiting for us to provide the user input. So let's say we give it a name like John Doe. Hit enter. You can see that our name basically has been passed and has been displayed onto the echo statement. You can also try to pass multiple variables at a time, values into multiple variables at a time. In this case, we pass the first and last name into the name variable. We can change this, so we can just go back and make a small modification. Let's say we basically give it something like enter your first and last name, and we would like to receive this information into two different variables. So we would write something like this, and you can basically execute the same command as before. Let's say John Doe. Okay, let me go back. Oh yeah, you can see the F name has to be displayed. If the names don't match, the variable will not display the content. And yeah, so this is what happened. So we can go back to John Doe, and you can see the first and the last name has been displayed. So yeah, this is one way to handle multiple insert of values at a time into the script. We can also try and handle spaces in the user input. Let's say if we are needed to accept a full sentence as an input instead of breaking up the string statement into multiple values, you have a solution for this. And for that, you will have to write something like a -r tag, so as to prevent backlashes from being interpreted. So we can basically go back and modify this same script, and let's say instead of the first and last name, we give it a, let's say, enter a bio, maybe a short bio or something like this. Go into -r and write bio. So at this point, we would basically accept all that string value or all that string statements into your bio variable, and here we would echo out your bio, something like this. So yeah, and we will display that information out onto the, let's say, onto this. For the purpose of this, let's just try to execute this, and let's say vi user input.sh. Once you enter, okay, sorry, I need to go back. As you can see, we can now write as many let's say statements as before, but yeah, here I'm just giving you random for the purposes of this. I'm just writing some random lorem ipsum, and yeah, so this will keep on going. And as you can see, instead of breaking up into different variables, we can now pass an entire string, and it can be as long as you are required. And yeah, this basically allows you to take an input as you have exactly entered. Another way is to use the -p, which is an option for inline prompts, which will make your script more user friendly. and would display the prompt on the same line. So we can just basically go back to the same script. Let's just try to modify this. Let's say you are trying to enter, let's say, an age. You can do that as well, but instead of reading it onto another line, we would basically read it with the echo statement itself. So we will write echo hyphen, so here we will write read hyphen p followed by, let's just say, an age, enter an age, and we will basically write it as age. And yeah, so this is pretty much the way that would look like. I would write age here. So you can see that we just combined two lines together with the help of hyphen p. We'll write and quit, we'll go back and hit enter. As you can see, unlike before, now we are able to prompt on the same line. So here we'll give it a random arbitrary value, and you can see that it basically displays out that arbitrary number. So yeah, read hyphen p followed by a statement prompting the user to basically insert an input statement is basically taken up by the variable age, and without any separate echo statements, we have done so with the help of this specific command structure. This entire thing can also be modified in a way to insert sensitive passwords, allowing us to hide the user input. So for that, we can do the same process again as before. We can modify the same script, and we would write something like, let's say, instead of hyphen p, you will write hyphen s, and we would prompt the user to enter admin password. So this structure would look somewhat like this, and we would enter the value into password. And yeah, so, and we will echo out the statement echo e hyphen n. Let's just give it a new line, escape sequence. Instead of printing it out, we will just say your password has been saved. So yeah, this is the way we would do it. The only difference here is that whenever we handle sensitive inputs like passwords, the hyphen s tag or option would hide your user input. So your typical characters won't be appearing, and they would be dotted in nature. And the hyphen n is basically a new line character which would basically suppress, which will basically appear on the next line. The issue is with the hyphen s, it would basically suppress the new line character. So let's just try to execute this. Let's just go back. I have made a small mistake. Oh yeah, I forgot to add an inline hyphen p to display this prompt on the same line. So yeah, that's pretty much it. Go back, let's just enter some password. Like, as you can see, the value that you just inserted would not be visible. This is typical of the passwords that you insert while you are trying to install certain packages. This is one of the better advanced way of doing user inputs. We can also modify this in a way to have a timer. So let's give a user a time limit so that the user has to input the values within a specified time period. It could be in seconds. So let's just create a new script. Let's say timeout .sh. Go into insert mode. So yeah, we will basically do that by using another option or a tag called -t followed by the time in seconds. So here we are basically reading the user input with the timer mentioned as 5 seconds, and we would like to take the input on the same line, so we mention -p. Let's write enter your, let's say something like enter your um, favorite programming language. Let's just shorthand. And we would basically take this input into a variable called language, and yeah, let's just echo out the statement, echo -e. Let's just take this user input through your values are $language. So yeah, here what we are doing is that we are basically giving the user a timed insert. So let's just write in quit, let's write bash timeout. So here we will write like Python, hit enter. Sorry, let me just see. Oh yeah, small error. Okay, let's just shorthand this just for the sake of simplicity. Remember, your variable terms have to match, otherwise you will not see your values. You can write something like Python. As you can see, our values were correctly inserted, but if we try to overstay our welcome, this will automatically close and it will exit without taking an input. As you can see, since I did not insert a value within the specified time limit of 5 seconds, it would automatically close. Yeah, so as you can see, so the value which was present within the variable $lang became empty as the user failed to enter your input value, and this was one of the ways to gracefully handle an empty input statement. So yeah, now we can try to combine all of these parameters into an advanced scripts. Let's say we try to create command line arguments for an automated way of handling missing inputs, and we could basically validate some inputs dynamically. So here we would like to take use of positional arguments and some other stuff as well. So let's just try to take user inputs with the help of the read statement, with the username and age being the arguments, and if there are some missing arguments, we will basically prompt to the user in an interactive manner. So we would use the -p in order to do so. So let's just go back into insert mode. We'll clear our workspace. Let's create a new script called user detailed. Let's just say user details.sh, go into insert mode and /bash. So yeah, this is something like we do as always. So let's say we basically check the first argument. So we will write something like if. So in order to do this, you would basically use -z. So this would basically specify the specific argument that you're using. So here if you write if -z followed by $1, so here you are basically checking the true value of this argument, if it is empty or not. So we would write then read -p, enter your name. So since we are accepting the name, we basically check this, and if it is empty, we would basically take it into this new value, else we will just simply give it to name and close. Now let's do the same process for checking the second argument. So yeah, we basically give if -z. We'll check the second argument. Then here we will be reading the age. So let's just give it age, and we will write else age is $2. And yeah, we will now write echo. We'll print out these details, user details. Let's just say name, $name, and age, let's say age. Yeah. So yeah, what we have done here is, so yeah, we have the first argument is empty file -z updated $1 would prompt the user to see or again enter the value features, and that value will be assigned to name. See, always give an executable if the same structure follows for the second argument as well. Execute this file. Let's just try to demo this. Try to break down our clarity did. So just move forward. Bash. As you can see, the details if $1, which is the first argument, not provide any of the -z values, it has prompt the user with a read echo statement asking the user to input a value into name. If this value is not empty, we would directly pass our argument into the variable name, and this same process also happens to work for our second argument as well. So let's just try to pass some values into our script. Let's say we give it a random terminology, and as you can see, since we just passed a name and an age, both of those values by the age. If you had enter, and you can see that our last echo statement, which is regarding the user details, has been printed out. But if we say without a doubt we don't pass any values, and once you hit enter, you would see that this has now triggered our prompt through the read command, and now we are asked to insert a value. Let's give it a value of something like John Doe and an age of something like this, and as you can see, the values were accepted, and this works out with the help of -z. So this is a very interesting way to work with scripts, as it makes your command structure more flexible and allows for CLI arguments, which looks out to be a little bit more interactive. So yeah, we basically have ensured certain mandatory fields would not be skipped, and in a way we have sanitized our user input. Let's say we would like to handle for missing data. Whenever the user misses some default value, we would basically replace it with our own defined default value, such as, let's say, if the user doesn't enter anything, we give it a default value. So let's just say user default. In this program, we would try to basically enter a username. If the user fails to enter that value, the default value would be set to guest, and we will take his nationality as well. If it is not there, we would set it up as an undefined value. So let's just go to the scripting bit. We would basically write bin bash, and let's just read and prompt the user on the same line, enter your default username. Okay, sorry, we'll just prompt the user as just your username. Let's say default guest, and I will give it a username. If this value has not been entered, we will basically assign a default value within curly braces as username as guest. Now let's try to define his nationality, enter your nationality. Let's just say unknown. Something like this. We will accept that into some value like country. If this value has not been defined, we would basically enter this value through our curly braces. We will define this as, let's say, unknown. We are probably going to be using the elephant tag here to make it a little bit more easier to recognize. So yeah, and we'll just echo out this value into the terminal. So we'll write user information, something like, I guess, username is from country, something like this. So before we exit, what we have set up is dollar followed by the curly braces, and within which we have our default value assigned to the same variable. If this variable is empty, it would take up the default value. This would ensure that the script never stores empty values. Now let's just try to execute this. Let's just go to bash, user default, and let's just say let's just hit an enter here. Since we are writing some value, let's just not give the first value, let's give it some national nation information and hit enter. You can see that the user information is guessed, which is the default value, since we did not specify the name. But since we provided the country, you can see that that value has been displayed. So yeah, the username basically has defaulted to the guest. And yeah, so this is a way to handle variables which may remain empty, and therefore could lead to errors if you are planning on inserting a specific value. Yeah, the next thing we can try to do is, let's say, some real world scripts which might be commonly be used. Let's say we basically automate user account creation, something simple like we would just set up a Linux user account, accept that username through the CLI, and yeah, so let's just try to use some different means. We can use some different tags. We will use id -u to basically run the script as you root. So here we can basically randomly take some data which is pre-existing. So let's just try that. Let's just clear our workspace. We will create the script as, let's say, vi create user -.sh to insert mode. Okay, sorry, bin bash. Yeah, let's just check for the sudo privileges first when the user executes this. If, let's say, $id -u, you basically are getting the script to run in the root, and it's not equal to 0. It means that this script, if it is not in the root, it shouldn't be in the root. That's what we are trying to do here. We'll basically echo out this script must run as root, something like this, and we will exit and close. But yeah, if this is not the case, we will basically accept username and as an argument, So let's just again write, let's just try to handle the error. If it is empty, let's just give it this, it will check if this is empty. If it is empty, we'll basically prompt the user to enter the username, else we'll write username equal to $1. Okay, $1, else we will just give it to this specific variable if this particular value has been inserted. And let's just try to validate some of this information. If the user has basically entered empty value, we will just say, we'll just check that information. Let's just say -z, we'll basically write $username as a double measure of correction. You will just see, we'll echo username count be empty, some message like this, and we will exit out of the script. So yeah, once that has been done, we will basically create this user account is created. So let's just say user add, user add -m, and we'll write the message, the user name, and echo username has been created successfully. Yeah, so something like that. So let's just try to get to the basic nitty-gritty. So what we have done here is that first we are checking whether the script is running in the root. If it is 0, it means it is in root. We would later check if our arguments which we have taken from the user are empty or not, and as before, we would basically prompt the user a read command to enter that value, and we will just assign it to the username value. And here we are just checking it again if it is an empty value, and yeah, and with the help of user add, we are basically creating this new user. So yeah, let's just update our chmod statements with regards to the privileges which we have assigned to this specific script. I have provided that executable privilege already. We will run this script in the root with the help of sudo. We will write create user.sh, and here we would write the name of the specific user that we wish to create. Since we would like to test out our prompt correction methodology which we just implemented, we will write, we'll just hit enter, and since you can see that since we didn't provide an initial argument, it is asking for the new username. Let's just give it a random username, and here you can see that the user was successfully created. So yeah, that's one way of working with this kind of a script. Let's just say now we try to implement a kind of a logging system which would track our user actions whenever we are prompting that specific script. So we would like to log our actions with some timestamp, and we would basically accept an action description through the input or through the CLI or the read. So let's just try to set up a log script. Here I guess I will just try pwd, and I have this specific location. Let's just say I create a new let's just say new and empty custom script .log file for the process of doing this. Let's just say scripts.log and hit enter, and as you can see I have that specific log statement. Let's just say pwd custom scripts log. Okay, we will just copy this for the purpose of specifying the location, and now we will create our log underscore actions .sh. And yeah, we will go into insert mode, go to bin/bash, and yeah, we will just set up our log file as the state as our script that we just copied. Paste selection, and we'll go to insert mode. We'll just write custom script .sh.log, something like this. So here now we will accept a log message, and we will write if, we will check whether our input statement is empty, $1. If this statement is empty, we will prompt the user to enter an action description, so description, something like this. We'll insert this into action. Else, if this value has been provided, we will just directly take it from the parameter that the user has passed. And yeah, let's just try to again validate this. Let's just say if this value that we just accepted through action is again still empty, we will just say just check this action, and then again prompt the user with a message with an echo. Let's say using echo, we will just say error action description is needed or something, and we will just exit. Here we would like, as I have mentioned before, we would like to append a date, let's say date time information to this entire thing. Okay, let's just append. So we'll write echo dollar, say date. We'll write something like the year, %y, the month in YYMMDD, as well as the hour, minutes and seconds. So here this is the format that we will follow in order to take that specific information. So we'll take the data as such, something like this, and this is our action. And we will just say, and we'll just log this into the log file that we just have, and we'll just say echo action log successfully or something. Yeah, so this is our structure. Let's just so yeah, what we have done here as a recap is that we would log our actions with timestamp using date, and we basically have the CLI and interactive inputs implemented, and all that log data would be sent to our log file, which we have already established here just a few minutes ago. So let's just go back and try to execute this specific command. So yeah, we will now try to execute our file with bash. Let's just say log action.sh, and let's just say user login successful, some message like this, and hit enter. And as you can see, we have just logged our data. In interactive mode, if we just give let's say we just don't pass any action, so here it would ask us to enter an action. Let's just say again we'll just pass user login. Oh, sorry, let's just say user logged in, some message like this. Okay, let's just try that again. So system backup. Okay, let's just see what is happening in our system log. Yeah, as you can see, our data has been logged in successfully and all the timestamps have also been saved. So yeah, I hope you understood something interesting today with regards to working with read and working with user inputs in an interactive manner with the help of CLIs and more. And yeah, so I will see you in the next one. Bye.